Now we're going to look at another test that's going to allow us to handle certain series with negative terms, but only particular kinds of series with negative terms, right? And these kind of series are called alternating series because why? Every other term is a different sign, right? One term's positive, the next one's negative, the next one's positive, the next one's negative, and so on. It doesn't matter where you start. It could be either positive or negative, but what's important is that the sign alternates. Get it? That's why you call it an alternating series. All right, so if I have an alternating series, notice here that the BNs are greater than 0. Okay, what makes things positive and negative then is the -1 to the n-1. The BNs are greater than 0. This is what alternates it. So what does the alternating series test tell us? It says if we have an alternating series and if Bn plus 1 is always less than or equal to Bn for any n, in other words, the next term is smaller than the term before it, or it could be the same. So if that's always true, and if the limit of the BNs is 0, then the alternating series test tells us the series does what? Converges. Okay, so let's look at a particular example. Here's one example. Summation, n running from 1 to infinity, -1 to the n-1 over n. Okay, that's an alternating series. What's Bn? Bn is 1 over n, so that's strictly greater than 0 as required. So now I just need to check, are these two criteria satisfied? Well, Bn plus 1 is 1 over n plus 1, and Bn is 1 over n, and since n plus 1 is bigger than n, 1 over n plus 1 is less than or equal to 1 over n for any n. This criteria is satisfied. Now I need only check that the limit as n tends to infinity of Bn is 0. Well, what is the limit as n tends to infinity of Bn? That's the limit as n tends to infinity of 1 over n, and sure enough, that's 0. So I have an alternating series. Criteria 1 is true. Criteria 2 is true. What do I conclude? That this series converges by the alternating series test. Okay, so that series converges. By the way, we have seen this series previously when we talked about absolute convergence. And we noticed that this series does not or is not absolutely convergent. So what I've given you is an example of a series that is convergent. This series is convergent, but it is not absolutely convergent. All right, now let's go to our next example. The next example is the summation -1 to the n over n plus 2. Notice that my -1 to the n, that power is different than -1 to the n-1. It doesn't really matter. The only thing that matters is that this term goes from positive to negative to positive to negative. And both of those do, right? All right, so what's my Bn? Well, my Bn is everything except this. So it's 1 over natural log n. And as n runs from 2 to infinity, 1 over natural log n is strictly greater than 0, and that was one of the requirements. Notice I cannot start my series at 1 because the natural log of 1 would be 0 and the first term would be undefined, and that wouldn't be good. All right, so it's an alternating series. What do I have to check? Just two things. Bn plus 1 is 1 over natural log of n plus 1, and Bn is 1 over natural log n. Well, since natural log is an increasing function, ln n plus 1 I know is bigger than ln n, hence 1 over ln n plus 1 is less than or equal to 1 over ln n. So criteria 1 is satisfied. Now I need only check criteria 2, which is take the limit of b sub n, that's the limit of 1 over natural log n, and as n tends to infinity, that goes to 0. So criteria 1 is true, criteria 2 is true. By the alternating series test, I conclude what? That this series converges. Now I've given you two examples of series that converge by the alternating series test. Remember, to apply the alternating series test, you first must have an alternating series, no kidding. And secondly, you have to verify these two things. I think I'm going to stop now. I hope everybody is doing well, and I would like to say bye.